Hey, welcome. Today we're diving into something that's, well, it's way more than just software. It's a project called the Spot-On Encryption Suite, and it's really a radical vision for what our digital privacy could, and maybe should, look like.
But before we get into the weeds, let me just ask you this. What if all those digital locks protecting your bank account, your private messages, everything, what if they all had an expiration date? What if a new kind of key was on its way that could open every single one of them? I mean, it sounds dramatic, but that's pretty much the reality we're heading towards. The digital armor we've built our entire modern world on, it's starting to show some serious cracks, and it's because of two huge, game-changing threats.
So you've got this two-front war happening. On one side, there's a problem we have right now, metadata surveillance. Even if your messages are scrambled and unreadable, the digital breadcrumbs you leave behind, who you talk to, when, for how long, can paint a scarily accurate picture of your life. And then, looming on the horizon, you've got the quantum threat, a totally new kind of computer so powerful, it could just shatter the very math our security is built on.
And look, this isn't some far-off sci-fi idea. Way back in 2016, the U.S. National Institute of Standards and Technology, that's NIST, they sounded the alarm. They put out an official statement saying that RSA, one of the most common types of encryption we use, is basically broken once quantum computers arrive. The clock is already ticking.
So what's the big deal? Why is this so different? Well, think of it like this. A normal classical computer trying to break our encryption is like trying to find one specific grain of sand on a giant beach. It could do it, maybe, but it'd take thousands of years. A quantum computer, using something called Shor's algorithm, doesn't even search the beach. It's like it can see all the grains of sand at the exact same time and just picks out the right one instantly. It's a total game changer.
So, to fight something this big, you can't just throw a software patch at it, right? You need a completely different philosophy. And this is where the Spot-On project gets really fascinating. It treats privacy not as some optional feature, but as a fundamental, non-negotiable right.
This quote from the source material, it just says it all. Freedom is the respect to the other's ciphertext. It flips the whole conversation on its head. This isn't about having something to hide, it's about having the right to a private space that is respected by others.
And this is so important. You know that old line, "I've got nothing to hide, so why should I care?" This completely dismantles that. Encryption is a form of digital self-defense. It's the tool that allows for private discussion, for organizing, for just thinking freely. All things that are absolutely essential for a healthy democracy and for protecting basic human rights. It all comes down to one question. Who controls your communication? You or someone else?
Okay, so that's the big idea, the why. But what about the how? How does Spot-On actually plan to deal with these massive threats? Let's start with the big one on the horizon, the quantum computer. Well, the answer has a pretty cool name. Post-quantum cryptography, or PQC for short. This is a whole new family of encryption algorithms. They're built using entirely different kinds of math problems that we're pretty sure are going to be tough for any computer to solve, whether it's classical or quantum.
And Spot-On was way ahead of the curve on this, putting these kinds of quantum-resistant algorithms into its toolkit long before it was the popular thing to do. But here's the really cool part. It gives you, the user, the choice. The source material calls it defining your own cryptographic DNA, which is just a perfect way to put it. You can literally decide to use these next-gen algorithms instead of the old, vulnerable ones.
All right, so that's the future-proofing part, the defense against quantum computers. But what about the problem we have today? Right now? What about all those digital footprints we leave everywhere? The metadata that reveals who we're talking to?
Think about how most messaging apps work, even the encrypted ones. A message goes from you to a server and then to your friend. It follows a clear, traceable path. It's kind of like sending a letter in the mail. Sure, nobody can read what's inside, but anyone can look at the envelope and see who sent it and where it's going. That's metadata.
Spot-On's approach, this echo protocol, it's wild. It's completely different. Instead of mailing one letter to one person, imagine photocopying every single message on the network and sending it to everybody connected. The whole system is just flooded with data. It creates this giant storm, and trying to pick out one single conversation in that chaos, good luck. It's next to impossible.
Okay, but you're probably thinking, wait a minute, if my computer is getting everyone's messages, how on earth do I find mine? And that's where the magic happens. It's called an echo match. See, it all happens right there on your own computer. Your Spot-On software gets a fire hose of encrypted messages, and it tries your private key on every single one.
Most of the time, nothing happens, and it just passes the message along. But when it finds the one message that your key can unlock, boom, it's a match. It shows it to you, and no one else on the network has any idea that you were the intended recipient.
So when you put these two huge ideas together, the quantum-proof encryption and the metadata shredding protocol, you're not just making a better version of what we already have, you're really building the foundation for a whole new era of what encryption can be.
The source material has a name for this. It calls it the era of exponential encryption, and it all rests on these 4 pillars. You've got multi-encryption, which is like wrapping a secret inside another secret. You've got systems designed from the ground up to resist metadata analysis. Then there's diversification, giving users that crypto DNA to choose from. And of course, quantum resistance, making that critical leap away from the old standards.
So you see, this is way bigger than just another private messaging app. The ultimate goal here is to create a world where real, meaningful privacy isn't some setting you have to dig for in a menu. It's just the default. It's woven right into the fabric of how we communicate. Imagine being able to talk, to share ideas, to just exist online without someone logging your every move. That's the future this is pointing towards.
And all of this brings us to one final, really powerful question the source material leaves us with. Are we going to build a future where strong encryption is like a seatbelt, a standard, expected safety feature for everyone's digital life? Or is it going to stay some kind of complex secret science that only a few experts really get to use, leaving everyone else vulnerable? Which future we get, well, that's really up to us.